Alright, in this video I will be going through section 4.2, and so let's go ahead and get started. And I knew I was going to have to do that. I need to move this just a little bit. So we need to review some things about slope and lines. So first of all, slope is a numerical measure that is given in this ratio. It's rise over run. Basically the difference in y over the difference in x if you're given 2 points. So notice this is the first point, this is the second point. I'll plug, so y sub 2 is just the y value of our second point, x sub 1 is just the x value of our first point. You just plug the numbers into the formula, here we get negative 5/4. So that's the slope of the line that goes through these 2 points. So again, this is just a quick review of things we need to know about lines before we jump into our lesson here. Slope-intercept form. So that's the y equals mx plus b, where m is the slope of the line and b here tells us the y-intercept. It's always the point 0, comma, that number. So here m is 3 and our b is negative 2, so the y-intercept is 0, negative 2. Here you have a slope of negative 1/2 and the y-intercept is 0, 4. So if you were to graph these two lines, excuse me, you would start at the y-intercept, 0, negative 2, and you'd probably want to write this as 3 over 1. Whoops, and I just wrote it as 3 over 3. Because you need a rise and a run. So you rise 3, so you're going to go up 3, and then your run is 1, so you go right 1. So slope positive, you always go up. Since we're going to go from left to right, our run's always going to be positive, and this is the positive x direction. Notice to graph the other line, you start at the y-intercept 0, 4. You go, now one thing I want to mention is negative 1/2 can be written as negative 1 over 2 or 1 over negative 2, or we could even write it as negative 5/10. But we're going to go down 1. I'm going to use this form here, negative 1 over 2. We're going to go down 1 and write 2. Notice if you had gone up 1 and left 2 using this version, you'd still get another point on the line. So we just start at 0, 4, we go down 1, right 2. You could keep doing that and you keep landing on the line. So we can quickly graph a line if we have the slope and the y-intercept. Now another thing I want to point out here, because this is going to be important what we're going to be doing soon. Notice it says for every unit change in x, so in other words, as x changes by 1 unit or just 1, the y value increases by 3. So if x changes by 1, y changes by 3. Notice here for every unit change in x, the y value decreases by 0.5 or 5/10. So in other words, as we go from here, as x changes by 1, what happened? We're down half or negative 0.5. So for each change, 1 unit change in x, the y value decreases by 5/10. Alright, so let's go on. And there's a couple more problems we need to do. So here we have, sorry, it says, use the slope-intercept form of a line to find the equation of a line with slope 4 and containing the point 1, 2. So here's our slope-intercept form. We know the slope is 4 and our point that they gave us is 1, 2. Now if this were the point 0, 2, we could just plug the 2 in here and the 4 would go here and we'd be done. But this is not the y-intercept. So what we can do is plug in the numbers here. Our y value is 2. Our slope is 4. And our x value is 1. By plugging the point in and the slope, we can solve for b. So we ended up subtracting 4 on both sides. We get b is negative 2. So our final equation can be written as y equals 4x minus 2. Now sometimes, in fact, in this section, you're normally just going to have 2 points. So again, if you want to use this equation, the slope-intercept form, to write the equation of a line, we need the slope and we need the y-intercept. Excuse me. The only thing, and honestly, if you look at the last problem we just did, what we really need here is a point and the slope. We don't have the slope, but if we're given 2 points, we can find it using our slope formula. We get m is 2, and so now we can use our slope of 2, and I would use the 0.21 since the numbers are a little nicer. So I'm using this information here. I'm plugging it into y equals mx plus b to find b, and once we know b, we can plug in our slope, and we can plug in our b value or our y-intercept. We get the equation y equals 2x minus 3. So one of the things you're going to need to be able to do in the homework, and when you're working with trying to basically find the line of best fit, is to use 2 points to do that. And you're going to have to be able to write the equation of a line. This is how we do it. All right, let's go on. Excuse me. Need to go here, so I'm going to have to change or adjust this camera here. Okay. So it says understanding the different parts of a linear equation. So this is going to be really important. You're going to have to interpret the meaning of slope and the y-intercept in some problems, and so hopefully this will help you to do that. And we have one more example. So data was collected to determine the length a golf ball will travel when hit by a golf club with a certain speed. The speed s is measured in miles per hour. So s is miles per hour, and it's the speed. And the length the ball travels, d, is measured in yards. The following formula gives the relationship. So d equals 3.18 plus 57.66 s. Now, we could reverse these. It really doesn't matter. The main thing is notice that d acts like y, and s acts like s when we're normally working with 2 variables, particularly on a graph. Now, d is actually in yards, and it's the distance that the ball travels, or the length. What did they say? They said, yeah, the length the ball travels. I don't know why they didn't just say distance, but they didn't. So first of all, let's go ahead and do number 1 here. Determine the slope in the above equation. Well, the slope is the 57.66. Determine which is the explanatory or independent variable. Well, remember the independent variable, that's normally x. So in this case, so I'm going to go ahead and do that here. It would be s. Notice y depends on the value of s. Determine which is the response variable. Now, when we said s, that's the speed, right? And here it's d, which is the length. Again, the distance is probably a way to think of that. Let's see, do I want to say anything here? I think that's good so far. So now interpret the slope. So if you're going to interpret the slope, you want to write it using rise over run, even though it's just 1 here. And remember what we talked about before. When we looked at the slope and it was, earlier it was 3 or it was a half, like for example with the one was 3, when x changed by 1, here x changes by 1, the y value changes by 57.66. Now what are these? Well, x is actually s is what's changing here, so that would be the speed of the club when the speed of the club, and we'll say increases by 1 mile per hour. The distance, or actually we should say the length of the ball travels 57.66, and it was yards. More. Now they worded things a little bit differently. I'm going to put up the wording that they use, something that's closer to what they were using. And the other thing they'll do is they'll say, as the speed of the club increases by 1 mile per hour, the model predicts that the ball will travel 57.66 yards more basically for every 1 mile per hour that the speed increases by. Next thing we need to do is interpret the y-intercept. Now that would be 0, 3.18. So basically that's when s is 0, or the speed is 0, or sorry, the speed when it strikes the ball. Let's see, the speed is meant, let's see, collected. The length of golf ball will travel when hit by a golf club with a certain speed. So if it hits the ball going 0 miles per hour, it's going to go 3.18 yards. That's basically what that's saying here. So if the ball is hit with a speed of 0 miles per hour, so basically you don't, like, you want to stop your swing and you just barely hit the ball, but you're going 0 miles per hour when you actually hit it, which sounds kind of strange. Then the model predicts the ball will travel 3.18 yards. All right. So that's one example. I'm going to go ahead and put up my other versions of those answers, and you can look at that. So this is probably closer to what you might see in my math lab or in my stat lab. There's one more problem to give you some practice. Let me see if I can actually find it. Oh, you know what? I didn't print. Oh, let's see. Don't have. I'm just going to go ahead and show that example. Sorry, I don't have a blank one here. We did in class. Well, actually, you can look at the notes that have been posted. But there's another example. I would encourage you to do that one from the notes, and then you can check your answers. Okay, so let's move on. So next we're going to talk about least-squares regression. Once the scatter diagram and the linear correlation coefficient show that the two variables have a linear relation, that's what we did in section 4.1, we can find a linear equation that describes this relation. One way to do this is to find 2 points in the data set that appear to provide a good fit, and then to find the equation of the line. So I was talking about this earlier. Notice that these are 2 points on the line. We could actually if we knew what those 2 points are, we can use them to draw the line of best fit, or at least what we could see looks like a pretty good fit. Now, is it the best fit? That's something that we'll look at. So let's see, we'll be doing homework 4.2, numbers 1 and 2. We'll get to that later. Actually, I've already made the video for that. Let's see. Let's go ahead and look at the definition of a residual or error. A residual is the difference in the observed value and the predicted value determined by the line of best fit. So this is what we are hoping to be, or wanting to be, the line of best fit. If you look at the actual observations, you can see that, so first of all, this is our prediction, basically this line. And you can see that the actual value of the observation is 4 more than the prediction. So we say that's a residual of 4, or an error of 4. Here you have a residual of -2. Notice this value is less than the value here. So we're basically looking at y values here. And so here you have a residual that's positive, and here's another positive. So that's what we mean by residual. What is the least squares regression line? The least squares regression line is a line that minimizes the sum of the squared errors. Now you remember they were positive or negative, and so we can square them to make everything positive and look at the sum of those residuals that are squared and look for the one that's the smallest. That's the basic idea. So an observed value is called y. A predicted value is called y hat. That's how we read that. So again, a residual is the reserved, it's actually the observed y value minus the predicted y value, or y minus y hat. So again, the basic idea of a least squares regression line is that it minimizes the distances from the observed value to the predicted values, indicated by the line. So I do want to correct one thing I said. In 4.1, we actually just showed that we had a positive or negative linear relation. It's in chapter or section 4.2 that we're actually looking for a line of best fit to model that data. Okay, so here's an example of a least squares regression line. So you can see it seems to be pretty much in the middle of all our data. And basically what happens when you come up with a least squares regression line is you find the line where these distances from the observations to the line, when you square them, is the smallest. So we're trying to minimize those distances basically. And that's the line of best fit. All right, let's move on to the next slide. There's another example. Notice here you have a negative relation, and let's go ahead and move on here. It says find the least squares regression line in StatCrunch and make a scatter plot. So you'll see that in the examples that I did for the homework. Again, it's 4.2, numbers 1 and 2. Basically, when you go to StatCrunch, you'll just choose regression and then simple linear, just like we did in section 4.1. Notice though, you've got your line right there, your regression line, least squares regression line. Notice it is backwards, the way they have it. I've seen it both ways. So here you basically have your slope, and here's your y-intercept, and you're going to normally round these to 3 decimal places, and that's all I need to talk about there. So So again, just to kind of sum up what we were saying, the sum of squared residuals is a measure to determine which line is the best fit or model for the data. The best fitting line or best fitting model for the prediction is the line that has the smallest sum of squared residuals. In other words, the distance from the observations to the line is minimized. The least squares regression line minimizes the sum of the squared residuals and is therefore the best fitting line. So I think we've pretty much, hopefully that makes some sense, but that's the basic idea. Okay. So finding the sum of the squared residuals. I actually do this in problem 2 for the homework example that I did. So it talks about making a table with the observation, the prediction, the residual, and the squared residual, and then sum the squared residuals. And actually you can see this on the next slide. So this is like what I did in the homework. So basically, in one part of the homework I was asked to come up with a linear equation using 2 of these points, and this is the equation that I got. And so now to find the sum of the squared residuals, you basically have your observations. So when we say observation, we're really talking about the y value. The predicted value is the value that you get from the line. So this was our line that we came up with using 2 points. And notice if you put in 2 for x, 2 times 2 is 4, and 4 minus 3 is 1, so that's y naught. If I plug in 3, you've got 2 times 3 is 6, 6 minus 3 is 3, and so that's this 3 here. If you plug in 4, 2 times 4 is 8, minus 3 is 5. That's where we got the 5. Now notice there is a difference. So if you actually, so for the first 2, they were the same, so when you subtract you get 0. Here we got 2. Similarly with these other 2 points, you end up getting the same y naught, or y hat. And so the only one that had a difference was this one, and when you square it you get 4. So we add all of these up and we get 4, and so that's the sum of the squared residuals. So that's how you'll do it for, in this case we had 5 points, and that's how it's going to look in the homework. The last thing I want to mention is, and this is what we had looked at when we were actually just a minute ago. So sum of the squared residuals. So actually the only thing I haven't really talked about, we already talked about the line, is for the regression line that you get through StatCrunch, you won't have to do that by hand. And this is where you'll find your sum of squared residuals. Alright, so hopefully that helps, and if you watch the video on problems 1 and 2 for this section, I think that should help you get off to a good start on the homework. Just let me know if you have any problems.